Welcome to Energy Practice Problems. So I'm going to do this first one in a video so that you guys can see how it works. And then hopefully after that, you'll be able to take on the rest of this worksheet and figure it out. I've written this at the top. The key to many of these problems is knowing that ME is equal to UG plus EK. Now this is mechanical energy is equal to gravitational potential energy plus kinetic energy. Now this only works in systems where there are no energy losses due to friction. So it's great and it should help you get through these problems a lot. So problem number one, Tony Hawk, your favorite skateboarder, has a mass of 70 kilograms. He has an initial velocity of 8 meters per second. So he's cruising along here at 8 meters per second, and he has a mass of 70 kilograms. At position number 3, so when he's way up here at the top of the ramp, he has velocity is 0. Velocity is equal to 0. Fill in the missing values. Assume no energy loss is due to friction. Well, that's great because that means we can actually use this equation here. And also it says use G for 10 meters per second squared. Awesome. So let's see. Position number 1. What do we have here? Well, Tony is on the ground here in position number 1. So his gravitational potential energy, well, if UG, gravitational potential energy, is equal to mass times gravity times height, and if his height is equal to 0, well, this whole thing becomes 0, and he has 0 joules for his gravitational potential energy. Okay, well, let's see. Kinetic energy. Well, we know from our NGSS equation sheet and also from what we did in class that kinetic energy is equal to 1/2 mv squared. Now, the important part about this is you have to do the square first. So, what if I plug in the numbers here, I get for his kinetic energy 1/2 times his mass, which is 70, times his velocity, which is 8 meters per second, but that has to be squared, and that has to be squared first before we do anything else. So that's going to be equal to his kinetic energy, and I'm going to go into my handy dandy calculator, and I am just going to type in 8 squared is equal to 64. Then I'm going to times that answer times 70, because that's his mass, and that gives me 4,480. Then I'm going to take that answer and I'm going to divide it by 2. That gives me an answer of 2,240 joules. So 2,240 joules. Well, mechanical energy now, if mechanical energy is just gravitational potential energy plus kinetic energy, well, 0 plus 2,240 joules is just 2,240 joules. Cool. All right, position number 2. Well, now he's been going 8 meters per second. He's going up this ramp, so I'm expecting he'd slow down. But the information they're giving us is it's 1 meter high. So I think we can figure out our gravitational potential energy. But also, since there's no losses to friction, I know the mechanical energy is 2,240 joules. All right, with my gravitational potential energy, UG is equal to mgh. His mass is 70. The gravity acting on him is equal to 10 meters per second squared. And the height that he reaches is 1 meter. Well, I know I don't need a calculator to do this. 70 times 10 is 700 plus, or times 1 is still 700. So I get 700 joules. So my gravitational potential energy is 700 joules. So he used to have all kinetic energy, but now some of that energy is being stored in this gravitational potential energy here at position number 2. Well, if I know that gravitational potential energy is 700 joules and mechanical energy is 2,240 joules, I can use, again, this equation up here to figure out my kinetic energy. And if I rearrange the variables by subtracting gravitational potential energy from both sides, I get the kinetic energy that he has is going to be equal to the mechanical energy minus gravitational potential energy. So that becomes 2,200